Chemistry behind film photography. Before digital cameras were made, something called film was commonly used and went through multiple reactions to record an image. Let's go and see this process close up.
The main component in the development of an image is photographic film, which consists of many different layers. Over here, we have a scratch-resistant layer that protects the film.
Underneath that, there's a light-sensitive layer called emulsion. Emulsion is made from gelatin that contains silver halide grains such as silver chloride, iodide, and bromide. Next, there is an adhesive layer, which is a firm, flexible plastic that provides support and binds the layers on top of the film base. Below the base, there is another adhesive layer with an anti-halation coating, which absorbs light, preventing it from being reflected back onto the emulsion.
The film is very sensitive to light. Once it is exposed to a small amount of light, it is able to capture an image.
Longer exposure times can create a motion blur effect. Too much light can overexpose the film, destroying the photograph.
The main chemistry behind film photography goes on in the emulsion layer. The suspended silver halide crystals are crystalline and cubic in structure and contain silver ions, halide ions, which in this case are bromide ions, as well as sensitivity specks, which are impurities such as silver sulfide. Impurities are important because they play a role in trapping light energy. If the crystal was a perfect structure, there would be no reaction.
When photons from the light hit these grains, an electron is ejected from the bromide ion, causing the ion to be oxidized.
The free electron moves around the crystal until it reaches a sensitivity spec. The electron is then able to combine with the silver ion, reducing it to form metallic silver.
The place where this occurs is called the latent image center. After this has happened 3 or 4 times, at the same point, a small clump of silver is formed, and the latent image center becomes stable. This creates a latent image which at this stage is invisible to the eye.
The darkroom is where the latent image becomes an image that is visible to the human eye. An important factor to keep in mind is that only red light is used in the darkroom because of its safe properties. Red light has a low frequency and less energy per photon, so it has less potential to knock out the electrons in the bromide ions. This prevents silver clumps from further forming, therefore protecting the photograph.
The darkroom consists of 4 components, starting off with the developer solution. It is a reducing agent that reduces the silver ions into metallic silver. The developer reacts faster with the areas where the light has already hit and formed clumps of metallic silver. Other factors that also affect the speed, intensity, and effectiveness of the reaction are temperature, concentration of the developer, and pH.
Since this is a redox reaction, the developer is oxidized and loses electrons. However, if the solution is not protected properly, it can react with oxygen in the air, which lowers its functionality. A preservative can be added to slow this process down.
The next step in processing the photograph is the stop bath. The job of the stop bath is to neutralize the developer that is present on the film. Because the developer is a basic solution, the stop bath is usually a weak acid. This prevents the developer from reducing the areas where a latent image wasn't formed.
After that, the film needs to be put into a fixer solution to remove the leftover grains of silver halide. This prevents the film from reacting further with light and forming another latent image. Since silver halides are not very soluble in water, they need to be converted to soluble compound.
A common fixer that is used is sodium thiosulfate. The silver halide crystal dissociates and the silver ions react with the thiosulfate ions, forming a soluble silver thiosulfate ion.
The last component of the darkroom is water. It is used to rinse off all chemicals and the remaining silver halide. The film is left out to dry.
The resulting image is referred to as a negative. This is because the areas of the film that received more light become darker than the areas that received less light, as more metallic silver was formed in brighter spots. Basically, the brighter areas become darker and the darker areas become brighter.
In order to produce the correct image, the negative must be reversed. This is done by passing light through the negative and onto photographic paper that contains an emulsion layer. When light is passed through the negative, the darker regions allow less light to pass through, causing the corresponding area to be lighter, and vice versa. The photographic paper then goes through the same steps as the film, which in the end results in a black and white image of what was in front of the camera.
This type of process creates black and white images, as the film can only detect and react to light and dark areas. However, color photographs can be created using specially designed film that are made up of 3 emulsion layers. Each layer detects a different color, red, blue, or green. When the final image is produced, the 3 negatives of each individual layer are combined to make a color image.
This process used to be long and tedious, but now due to technological advances, it can be done in a flash. Most people nowadays rely on digital cameras to capture memories.
Yeah, ever since buying a digital camera, I can only think of its positive points. There aren't any negatives.